Hello and welcome back. In this video, we will demonstrate how to solve for the radius of a sphere given its volume. And again, this is from the MCAS release problems in the 2017 problem 41 in part D. So let's start. I will read the problem. Please follow along. 41. Three objects are shown below: a sphere, a right circular cylinder, and a right circular cone. The radius r of each of the objects is 10 inches. The radius of the sphere will be changed so that the volume of the sphere will be equal to the volume of the cylinder. So what this scenario is telling us is that the previous statement is no longer correct for the sphere. Right? We are actually looking for the radius, so disregard the 10 inches for the sphere. What other information do we have? We have that the volume of the sphere will be equal to the volume of the cylinder. Again, it's a good thing that we take notes. So let's look at our previous problem. So the volume of a cylinder in part B was calculated, so that's a cylinder. In part B was calculated to be 2,000 pi cubic inches. Let's write that down. And so let's write that down and proceed. Again, just to help us, this is 41D. We are looking for a new sphere. That's a fantastic sphere. From the center, you have the radius. We don't know what the radius is, but we know that we're looking for the sphere, and the radius is unknown. We'll put a question mark over here. So radius is unknown. Do we know the volume? Yes. So it's from the previous problem. We have the volume of the sphere is equal to the cylinder, and this is again, this is how keeping pi in its original form help us. So we have 2,000 pi cubic inches. Oh, it's shaking a lot. I'll work on that later. So we have the volume, we have the radius. So let's go back to the reference sheet. Again, it's not about memorization. You can tell this is the fourth problem we're working through. I'm still going back to the reference sheet. So the MCAS reference sheet, following the text feature, we have conversions, area formulas, total surface area formulas, volume, circle formulas, right triangle, and special right triangles. We are looking for the volume, so going down the list, we have cube, prism, cylinder, cone, pyramid, and sphere. Very much like the first part 8, we are looking for the sphere. The volume is 4/3 pi r cubed. Let's write that down. So the volume is equal to 2,000 pi cubic inches, but the volume of the equation is also equal to, let's write it up here, equal to 4/3 pi r cubed. Since you have done the rewriting in your own words in part A, we will just skip that part. What else do we need? So given this equation, we have the volume of the sphere, because it was mentioned to us that it's going to be equal to the previous problem we set, the volume of the cylinder, which is 2,000 pi cubic inches. Over here, do we know what pi is? We will just leave it in this form. We are looking for the new radius. With that being said, we have one unknown that we're looking for. Let's plug it in and see what happens. So we have 2,000 pi. Cubic inches equals 4/3 pi r cubed, which we don't know. On both sides we see pi, so let's cross it out. Let's see. So 4/3 of the radius cube is equal to 2,000. So let's just cancel let's move the 4/3 to the other side. So we multiply by 3/4. 2,000 cubic inches is equal to, let's multiply on both sides, So 3/4 multiplied by 4/3, they cancel out to be 1. And let's see, so again, where this is about you using your resource, right? So we have 2,000 multiplied by 3/4. We have 1,500, right? So we have, let's just draw a line. So 1,500 cubic inches is equal to r cubed. What r cubed stands for is the radius multiplied by the radius multiplied by the radius. And so if we want to just look at the radius, we have to take the cube root of it. How it looks like would be, if you want to write it out, the cube root of 1,500 cubic inches is equal to the cube root of r cubed. So they cancel out, leaving us with, again, we're not going to do that. So let's see. So can you see this? So this is 1,500. So 1,500 raised to the 1/3. That's the how you look for a cube root. And so it would be 11.447. So it will be, see that, right? Perfect. So I'll leave this up. So 11.447, and when inch cube is being raised to being the cube, we're looking for the cube root, we have inches is equal to r. We are not done yet. We're not done yet, right? Let's see what the problem is asking us. Problem's asking us. So let's reread the problem. The radius of the sphere will be changed so that the volume of the sphere will be equal to the volume of the cylinder. We've done that part. Now part D. What is part D asking? By how many inches would the radius of the sphere have to change for its volume to be equal to the volume of the cylinder? Show or explain how you got your answer. So this, in this question, while we have the correct radius, it's actually looking for how many inches would the radius have to change, right? And what is it's changing from? It's changing from the original one, right? It's changing from 10 inches. So the answer is looking for change from the original part. So the original, let's just block this out. So original radius, and is 10 inches. New radius is what is this? 11.447 inches. And if you want, so when you want to look for the change, you want to look for the difference between these two, and we will look for 11.447 inches minus 10 inches. We do that on the calculator. Let's take a look. I should be able to do this, but we have 11.447 minus 10, the original one, giving us 1.447. So the by how many change? So the radius change is 1.447 inches. Box your answer. So that will be it. Can you see it? Perfect. So that concludes problem 41. And so following this, if we know the volume of the sphere to be 2,000 pi cubic inches, the radius would have to be 11.447 inches. And if you look at the change between this and the original one, where the radius was 10 inches, you will have a change of 1.447 inches. Thank you for watching. Goodbye.